Create and execute Windows command files. Quicksort function. This video shows a quicksort written in batch code. The bubble sort was described in a previous video. That sort was simple to program, but as mentioned in that video, is very slow for large lists. The quicksort is much harder to program, especially in batch code, but is much faster than the bubble sort. Did I mention it's much faster? You are watching a Tom's Tech Notes video. If you like this video, please wait until you are finished watching it, then click my name, Thomas Wallace, to visit my channel page. A welcome video will play to describe my other videos. The literature predicts that the bubble sort increases as the square of the number of items. So that as you go from 10 to 100 items, that's times 10, but the square of that is 100. So it should take 100 times as long to sort 100 items as it does for 10, and it's pretty close. And then the same thing, about 100 times as much for this increase, and again, it's pretty close. The quicksort time, on the other hand, increases as n times the log to the base 10 of the number of items, n log n. And that means that the quicksort time will increase at a much slower rate than the bubble sort time increases. And that means that the quicksort is a much faster sort. It's pretty amazingly fast. If you look at how long it would take to sort 10,000 items, I measured it on the quicksort. It took 10.7 minutes. I calculated on the bubble sort it would have taken 15.8 hours. And yes, those numbers are correct. The quicksort is much harder to program or to modify from my code. We'll do a code walkthrough now. First of all, the test driver, and I have modified the code so all the output will go to file temp.txt. The test driver turns off the echo, and it is the only part of this sorting package that has the set local enabled delayed expansion statement in it. I don't put that statement in the quicksort routine and the bubble sort routine so that I can share the array easily from the test driver to the sort routines. You could change the code so that the set local was used in all of the different routines. Then it's a little trickier for the syntax to pass arrays back and forth that way. So if you want to modify the code to make them all self-contained with set locals in them, feel free. And it's also slightly harder to pass results back from a routine if you have enabled delayed expansion in that routine. Again, if I only enable it in the test driver, I don't have to worry about passing parameters back. They're simple to pass back from the called routines. And the arrays, I can just use the same array easily in all the different routines, both the bubble sort and the quicksort routine. It's the same array throughout. First of all, I set up the test. How far do I want to go? And I'm always starting with 1, but in this case I'm going to go 1 to 100, but I can change this number to test it for different numbers of items. It puts output, a little bit of output on the command.exe window so you can see what's happening, but it puts most of the output in the temp.txt file so you can examine the results, especially when you're debugging it. First thing it does, it fills the array that you're going to sort with random numbers. This is a random number function available in batch file code. The way it works is you need the delayed expansion here, otherwise each time through this loop you'll get the same random number, which isn't exactly random. And then the function is you take the random number, you multiply by the maximum value you want your random numbers to have, divide by 32768, and add 1. This is just a formula that will give you random numbers in the range of 1 to last 1. Remember, last 1 is the number of items we're going to be sorting. We go ahead and display that list of random numbers in the temp.txt file before we sort. We display the start time in both the temporary file and on the command.exe window. Then we call the quicksort routine with the specified range of values. And remember, it's sharing the array X that has the random numbers in it that we're going to be sorting. When it returns from the Quicksort routine, It displays the end time in both the command.exe and temp.txt file. Then it lists out the sorted array. Then it pauses, and then the command window will close when you hit any character after this pause, because that's the end of the program. The bubble sort routine is called by the Quicksort routine when a partition size is 10 or less. We'll call this bubble sort routine. So the bubble sort routine's already been described in the previous videos. Bubble sort routine sorts the 10 or less item piece of the original array in place and then returns to the Quicksort routine. Here's the code for the Quicksort routine, and as I mentioned, it is fairly complicated. The two parameters are the start and the ending indexes in the array. I'm putting the output into a temporary file so that I can examine it. This sets the limit at which I will call the bubble sort routine to sort the smaller pieces. Each time you come up to the loop, it says, are there any items in this stack, two variable stack, that need to be processed? And I start out by putting the start and end of the array in that stack, passed in as start p and end p from the parameter. So there is at least one in the array for the first time. After we have removed the bottom item in the two arrays for the starting and ending pointers to the piece we're now working on, we check whether or not we have any pieces left to work on. If we do, in those two arrays. If we do, we remove the starting and ending pointers from the arrays, and we're going to get ready and set up a partitioning pass. So we decrement the number of items remaining in those arrays that we just removed it from. We set our initial pointers to the top and bottom item we're looking at to the top and bottom of the piece we're in. Then we remove the item we're looking at using those two pointers, the TF and the TL pointers. So these two are the actual items we're comparing. And then we go into a loop. Here's a description of how the partitioning phase of the sort program works. I'm using a printout of part of the previous sort execution. So let's say we pulled out of our little array of which piece to work on next, and what we pulled out was start at item 1 and end in item 32. Now here's the partitioning phase. First, compare the upper and lower, which are the XF and the XL, this 41 and 38. As long as it's less than or equal, but it isn't. It's 41 is greater than 38. So you don't do what's in the loop. You interchange the two items. We started with 41, so the 38 is going to come up here, and the 41 is going to go down here. We started with 41, and that's crucial. I want to store it up there so we can remember what it was. Okay, we interchanged the two. Remember, we were in the loop that decrements the last pointer, meaning we've got pointers down here and we're bringing them up. But we failed this test, so now we're going to interchange the items, and then we're going to enter the loop where we're incrementing the top pointer. So we're going to keep looking at the number 41, which we just moved to the bottom. And we know we moved 38 up here. We know it's where it belongs, so we go down 1 before we start. That's this increment right here. Then we pull out the item from there, and we compare them again. We compare 54 and 41. This is the first and last, but down here, this is the first and this is the last. So we want the last one to be greater than or equal to the first one. But the last one's 41, and we're looking at the second one now, and 41 is less than 54. So this test fails. We go down and we switch them again. So now we're going to switch 54 with the 41, and we're going to do the same thing again. We're going to go into the loop where this is our initial guy. So now we're going to be looking at the bottom one and bringing the index up. So we're going to look at 7, and sure enough, we're going to switch again. We're going to switch 41 and 7. And now, this is our reference guy, we're going to bring it down from the top. So 76, 41, we're going to switch them again. So we're going to keep switching them back and forth until the two pointers to the upper and lower guys meet in the middle somewhere. So the number 41 is going to wind up somewhere in the middle, but the way we've done the switching back and forth, everything above it is going to be less, and everything below it's going to be greater. That's the purpose of the partitioning loop. When you finally get it where it belongs and everybody above it in the list is less and everybody below it in the list is greater, you do the final processing for that partitioning pass, and you figure out how many are in each piece because you moved it down to partition it into two pieces. Calculate the number of pieces in each piece, the number of elements in each piece. Anytime the number of elements is less than our limit or equal to our limit of 10, we call this bubble sort routine to sort that piece. Anytime it is not less than or equal to 10, we put it in that array of things to still be done, and we'll partition it later. We do that for both pieces from that partitioning pass. And then how do we know when we're done? We always go to the top of the partitioning pass, which is this labeled next part. We see, is there anything left to work on in those two arrays? If there is, we fetch it and we partition that piece. And we keep doing that until we come back up here and we find out, oh, we don't have anything else to work on, and then we're done. Thanks for watching my video. If you like this video, please click my name, Thomas Wallace, to visit my channel page to watch my other videos.